Thank you for your time, and thank you very much to give us the opportunity to be here. Paul is extremely busy, and he kindly asked me to represent us here. I'm Bertram DORN. Nowadays, I'm working in the office of the Chief Information Security Officer of Amazon Web Services. I typically nowadays could say I'm a fly at the wall. I don't know how this translates positively or negatively in Romania. But having been there for 34 years now in the industry, I might have touched something you use already. Give you an example, in the 90s, I've been maintaining the one big line between Munich and the USA where the internet has been connected over the Atlantic. By the way, I didn't know. It has been just another customer on the switch. So that has been very interesting after I found out some years later what I had in my hand. And similar with other stuff, I think I could prize now many things, but we'll come later to some areas where things have happened and we didn't know. Today's talk is basically focused on, well, how can AWS and the telco industry work together? So where do we have overlapping things? And one of the main overlapping thing, let's see if this works. Next. Yeah, that works. One of the main overlapping thing is what we call the culture of security. Security is not necessarily only a technology thing, and especially in cybersecurity. You know things will always go wrong. Sooner or later, we can build on that. Down there, when I explained to you, I maintained the line, we did a statistics at this telco, and we found out statistically in Europe, every day 2 or 3 excavators are hitting one of the lines. It's happening, right? You know that, yeah? So looks like we're on the same page, yeah? Sometimes we said, well, our 5-bit telex is more reliable than everything else. What are we doing today? WhatsApp or Telegram or something where we have little bandwidth and try to get our digits of little text through, which is, well, not necessarily a 5-bit telex. There's a lot of overhead, but the message is the same. Yeah, and even I see the same code from, what do we know, LOL or smileys or thumb ups and things like that. We typed that into a telex machine, and it came out in South Africa or in Japan. So nothing new, right? So there are things which stay, and there are things which evolve. And the culture of security is staying. That's an ongoing, repeating, never-ending topic. And I think that's very important, that we need to keep those culture topics in mind. And we see there are 3 or 4 important parts. And something which has been really enlightening while joining Amazon 11 years before is that everyone in Amazon is even incentivized launching a high security or high priority security ticket. That's literally in the first 4 hours of your life at Amazon, you get told, well, if you see something, launch a ticket. And then people even say publicly here in our websites internally, if you go to the ticket site or if you go to Amazon Security internal site, the first thing you see, well, if you don't know whether it's a CEF2 is the second highest priority we have. If you don't know if it's a CEF2 ticket, it's a CEF2 ticket. There is no one ever be punished by launching one of those tickets. And that culture is important because we distribute the ownership of the security process to 1.65 million employees. It's a little bit like Toyota in the 1960s, where everyone can hold the line, everyone can stop the production line. That doesn't mean we stop the production line, but everyone can send a signal, and that's the important part. So executive ownership does also mean people are secure if you do that. And also does mean our executive ownership goes that far that the CEO of Amazon Web Services, Matt Garman now, is reviewing high priority incidents every Friday. Just consider, you do something, it's going wrong, happens, and you might be on that meeting. And you might be scared and say, well, this is not where I want to be. But on the other side, what I say, well, typically that drives attention. So if you have the right attention, if you have the right attention of those who can do something, you can do something. And that's exactly how this meeting works. It's working backwards from the cause of error. It's going forward to how to protect that. And it drives management awareness because every employee knows that process. And it's not only there. That's a team where Paul is working. This is a team where I'm supporting in. We select those tickets, and we help the people to prepare. They're not running into a knife. I hope they don't feel that way. On Monday, we select it, or someone someone is selecting the tickets, the team around Paul, and then we help them to be prepared until Friday. And that drives the ownership also in the field that distributes the ownership of security. And why is this important for telco? Well, you know, if it's going wrong, you need to have the right culture. You need to be able to talk about your things. There's nothing worse in our community, and I said this in the beginning before we started here. We are all the good guys. We defend our population against the bad guys. We don't need to work against each other. Not in security, that's not necessary. Therefore, we have exchanges, therefore we have threat intelligence exchange, therefore we have other stuff. And what we want to export out of our community in Amazon is this security thinking, the success factor to distribute security to every employee. Also cybersecurity, not only safety. And that accompanies the psychology security. That accompanies people feeling well to talk about those things. And our success factor, for example, is that people like to do our security training. Who of you needs to do one of those trainings every year? Most, yeah. Do you like it? Yeah, okay, good. Someone is doing a good job. For example, we have a fast track. If you answer 10 questions correct, you can bypass the training. If you answer one wrong, you need to take the training. And we have contests. Well, have you done that? Did you fall through? So basically, we encourage a positive competition around security topics, and that is what drives also the motivation. And then, of course, there's education and others. And that also leads to something that if you are a developer in your own area, you should rely on something on the security side. Have you seen this going wrong? Well, who remembers Heartbleed? Okay, 1, 2, 3, 4, 5. So Heartbleed has been a challenge in the TLS protocol. Not in the protocol, that's wrong. In the OpenSSL-based implementation of TLS. And without going too deep into the details, we don't need to overrun the online translation. You basically send the remote side a packet and ask for, well, give me the next 10 gigabytes of memory, and the daemon fetched the next 10 gigabytes of memory off his memory space and sent it back. Nice. Funny enough, it turned out it has been one student in Germany writing that code. 1. And you see the problem. There has been no security team behind that. And also, there has been ownership maybe in implementing, but not ownership in running that. And to get this forward, you need to have everyone on board. And there is something where we are known to do that. You might have heard the word, don't create your own crypto. And I'm not talking about crypto money. I'm talking about the fundamental algorithms and implementations. That's a recurring thing. I learned this in the 80s. Like, Bertram, don't write your crypto code. Don't. I said, well, if I write my code, I confuse the Russians. That's good. That's the 80s, yeah, Cold War. So, confusing the Russians is a good idea. Doing this with code from a early starting carrier, that's also an interesting idea. But in the end, we know that if you run crypto stuff, rely on the community. Don't code your own crypto. Don't code your own algorithm as long as you don't have enough really good mathematicians you trust and they have a community process around that. And that's exactly what happens. If we look into what recently happened, that 2 algorithms have been cleared by FIPS to be post-quantum ready and ready for production. That's a community process. And again, back to telcos and the cloud providers, this is where we need to work together. This is where we need to join forces. Not only on DNS, which is very important, but also on the other fundamental stuff. So, culture of security, for our security culture, that's something which needs to be selected. In our case, we have also distributed the application security part. If you want me to talk about that, it takes a little bit longer. We basically train people to take their volunteering time on Amazon to help the AppSec teams to review stuff. So we distribute that. And that's, again, an incentive for people. And that's basically everyone's job. It's just a quote from our side. Security needs to be distributed. And if I'm talking on events like that, I'm really happy to be able to build a network to distribute security, not only in our company, to build a security network around us. And I can show you some things where we can help you. So let me make a short stop here. Is it the right way? Is it what you want to hear? Or shall I go into deep technical stuff or more strategy stuff? So originally I planned to look into post-quantum crypto. Well, might be hard, but there are good messages because we invest, and that will be interesting. We invest and we give this investment out to you as a telco. There, little hint, I can show you in post-quantum how you can save 30% of CPU time for each crypto operation.
Why don't you do that?
That's nice, yeah, because in the end that does mean, well, we can sell 30% more CPUs. We have stuff in networking, we have stuff in hypervisor, we already talked about culture. But okay, cryptographics, we know there is something coming. The industry is expecting cryptographics to be, the actual existing cryptographics to be compromised soon. Why is this important for a telco? Well, there might be people reading the traffic. There might be people storing the traffic. If we look around in the European Union, there are strong laws around that, maybe otherwise not, we don't know. So that does mean whatever you send out there as a customer, you need to anticipate that someone is sitting there and can record it. Now, that does mean whatever you encrypt today might be decryptable tomorrow. That even can be the case in storage. It's the same problem. Just storage devices are difficult to get. Yeah, if you don't lose your thumb drive or your laptop, the storage should be somewhere. Typically, I talk about the trinity of crypto, which are three things. The trinity of crypto is, first of all, the data, the algorithm, the key. And in communication, we need to make clear if it's leaving your house, it's public. Correct? Yeah.
Or even before.
Or even before, yeah. Thank you. In our case, it will be a little bit difficult because we, for example, run our own cables between data centers, and if you have 2048 fibers in one cable in 16 colors, it's a little bit difficult it's just too much. Yeah. But if you ever have had a bending coupler in your hand, you know what I'm talking about. However, if it's leaving your house, if you transmit it to the internet, to an IXP, whatever, you need to consider it's public. So, the data at home and on your drives are not public until someone breaks in. Shouldn't happen. But let us stay in the telco world where if it's leaving your device, I think we can say device is good, yeah? So if it's leaving your device, potentially it's public, so that does mean you need to protect it, and the protection will not necessarily fade away. Maybe there is an event where someone has enough qubits where there is a possibility to get into the data quick enough. And being a fly on the wall, we had that already. Who remembers DES? Triple DES? Yeah. If I tell you nowadays it's encrypted with triple DES, everyone smiles and says that's broken and all this stuff. And some companies made a lot of money out of selling new tapes to other customers to re-encrypt stuff. And if you load 3,000 tapes to your tape drive, you need a new tape drive, so there's money in it. So re-encrypting already happened once, if not 2 times, in our IT history, at least in my history. And it will happen again. Back to what I see as a fly on the wall, this is a recurring thing. It's not constant accompanying us like culture, but it will happen. And that is exactly where quantum computing is coming in, that quantum computing will be potentially able to take the actual mathematics in the Rijndael algorithm, which is in the advanced encryption standard, which is the base of the most things we do today, and make it visible. And that does mean in this stack, those things on the bottom will be invalid. Funny enough, fly on the wall, I've been, in my history, I met Whitfield Diffie and when I've been working with Sun, and he anticipated, you know what, he said in a community similar like here, well, I anticipate that being broken because you need to select the right prime number to make this algorithm working right. 5 years before, someone found out 99% of all servers in the internet are exactly working one prime number. Happened. You can look it up. What's the background is the Diffie-Hellman on prime numbers is working in factorizing, and basically there is a set of prime numbers out of the first, let me say, 512 bits or first something, and what the servers on the internet did in the implementation, they just choose the highest one, not a random one out of the set. Yeah, it's fixed. But you see, things are important to fight away, and I want to go to basically this slide here. How can we prepare as a community? So a little bit AWS, it's here. I'm working for them. I'm desperately supporting what we do here, because in especially on the library side, that's something we open source. So after Heartbleed, where the TLS implementation of OpenSSL with approximately 400,000 to 500,000 lines has been a challenge. And even before that, we already invested into our own TLS implementation called Signal to Noise, S2N. And that's public. That's open sourced. You can use it right now in your products. That is going down to 40,000 lines of code, and those 40,000 lines of code, approximately, are mathematically reasoned. So that does mean we had our mathematicians proving on a mathematical way that this code is doing what it's supposed to do, and that there are no exit ways out of that code to do something which is not there. And that is something where we invest at AWS. We have the right mathematicians to do that. We pay them. We go down this loophole. Or not only loophole, we go down this, what's the right word? The rabbit hole. And find the right bunny for that. And we not only take this on our side, we open source that. So one takeaway from today, well, you don't need to go into the code right now. Don't do that, maybe only if you want. But take away that there are ways out there to do things more scalable. For example, with S2N, that's there in the library section. And the other thing is AWS LC, that's libcrypto, where we do the same thing. We go in there. We found ways to take 30% out of the CPU time by the right implementation. And that is something, back to the topic of this talk, where we can work together. Because that is something which we give back to the community. The group is small enough. I'm monologuing like since 15 minutes. The questions.
Who are you working with at Waterloo?
Pardon me?
Who are you working with at University of Waterloo?
I need to find out whom we exactly work with. Matt Kampala is one of our lead mathematicians in this area. He wrote a lot of the post-quantum documents and is closely working with his team in the community. I'm more embedded into the German community. So I represent AWS also on the German post-quantum summit, things like that. But we'll find out for you, no problem. So, call to action, I would say. Yeah, if you as a telco, you should either go into your products or if you have suppliers, ask them, well, what's your post-quantum strategy? Good question, right? Yeah? There's one, please.
So, you said earlier, don't make your own crypto.
Yeah, don't roll your own crypto, yeah.
But with blockchain and Ethereum, for example, which I believe they made when they first started proof of work, they used SHA-3 with hardware. So that was successful.
Yeah, so the point is, to repeat for the others, so if they created the first blockchains, they used SHA-3 already, which is successful, but SHA-3 is already community-based. So
it was recently approved by NIST.
Yeah.
Yeah. But the question is about post-quantum. Like, there are 3 algorithms now that are published. Which one can we use?
2 made it in the NIST. 2, yeah. Even the third one, if I'm right, didn't make it. But 2 have been approved by NIST. And you can or cannot, that's another thing which I typically say that's a customer's risk appetite. Yeah, where do you want to go to? We have been seeing that some of the things have been broken, and also I say, well, don't let anyone grab your device because then you're dead. So physical stuff is something difficult, but go to the NIST implementation and 2 of them are approved by NIST now. So they made it, but they're still way in front of us because those algorithms need to be implemented, they need to be in the systems, they need to be used, and on the positive side, we are a little bit ahead here. A substantial portion of our infrastructure already is using post-quantum hashing, so we are ahead of that. The buzzword here, I don't know if regulators in the room, is basically crypto agility. Again, what stays? What's staying is that we need to be ready for change. And even with going to the next FIPS standard, you need to be ready for change. And being ready for change does mean you need to have your bill of crypto algorithms. So you might have heard the word SBOM, software bill of material. There's a new thing called, well, not new, CBOM. It's a crypto bill of material. Know what you use. Know what your customers are using. Know what's the implementation out there. Know where to invest. Know where you can make a change. Know where you can turn the needle for your customers. Whether it's in your endpoints, whether it's in your transport, whether it's in your routing. As far as I've heard, BGP is still interesting. Again, being a fly on the wall, 2003, I had a longer conversation with Radia Perlman about how to make BGP more secure and how to sign BGP updates. And we're still working on that as an industry, and that's my call to you. Address that. Because in the end, that's a recurring thing. Recurring is change in crypto and change in the algorithm, and to prepare for that, we all need to know what we are doing. We need to know the background. We need to know where do we have planted which technology.
Okay, question?
Yeah.
You asked about the opinions of the telcos in this hall. Probably there weren't that many, but the question is, have you any knowledge about such use cases at European level or worldwide implementations of PQ strategies in telcos?
Do I know telco implementations? I think that depends on how far you, how deep you see your integration stack. What do I mean this? Are we talking about base protocols, or are we talking about DNS over crypto channels, which, by the way, as soon as we do DNS over HTTPS, we have a privacy problem. We solve one privacy problem, but we have another one. So therefore, to answer your question, the question is, well, where do you stop in the protocol deepness? Do I see telcos doing the right thing on their, for example, portals and websites? Yes. Do I see telcos investing into on the line encryption? I'm too far away nowadays from that. So I have no insights. Do I see telcos doing new things? Yes. I'll give you an example. We nowadays have telcos which send their data stream from the radio tower to an AWS region, have all the compute there, and then have their customer data flow from our AWS installations to the internet. So it's not that the radio tower is directly talking to the internet, it's basically first of all going through compute and services on AWS. And that gives them the agility, because we might have the right tools to help them on this infrastructure to stay agile. I think nowadays you can't do more worse thing than not being able to throw your computers away every day and rebuild them.
Thank you.
Yeah. It's not a complete answer, I'm very sorry, because
Yeah, no.
there's things I don't see, but the things I see, for example, DNS or HTTPS implementation, TLS implementation, or something which is coming very quickly over the horizon is QUIC. I think I have it here, yeah.
Yeah, on the second column,
Yeah.
IETF.
So QUIC is coming very fast. For those who have not seen QUIC, QUIC is basically a on-packet level encryption standard, which is faster point-to-point than TLS. TLS has lots of fun. One of the fun is that I use TLS to ask questions to candidates if they want to join the AWS security side. Having a TLS in discussion is always there on the tech side. Why? And please make up the mind for yourself. But in our case, TLS, as of today, is a fundamental of our business. There's almost no API call, so no command to AWS, which is not encrypted on the wire by TLS. That does not mean that's the only thing. That's the other part. Yeah? We could talk about zero trust, which is another buzzword. I don't try to come here with all those buzzwords. Try to come here with collaboration. And collaboration is one of those things. Another thing which we can give you is Firecracker. Firecracker is a micro VM, which we also open source. The problem here is if you want to run quick workloads for your customers, you need to isolate them. A little bit warning as a technologist. If you want to think about containers, it's very good, but don't mix customers on them. And that's exactly the point. Another recurring topic for all of us is tenant segregation. If you run MPLS networks, that's just another cloud. Because in our case, the customers say, well, AWS or a cloud is just another computer. MPLS is just another person's cable, right? With tagged stuff on it. So tenant isolation is very important. I can't give you the solution for MPLS networks, but I can give you some solutions for separating your tenants on CPUs if you need to. And even in the telco world, you might have the need for that. And our micro VM called Firecracker is a great thing, which we also open sourced, where we invest so that you have something fast and quick to launch. And the fun with Firecracker is it gives you the possibility to do tenant segregation of one server. So basically you go out of the risk of having too much tenants on the same thing called kernel. Just a buzzword to take with you, as I said. And there are some slides around that. Last but not least, where we invest, if you really come to the AWS cloud, we have invested into our own hardware fleet for tenant segregation and I/O computing. So this is nothing which we open source, but it's available for every customer. As we are with the logo here, please allow me to do a little bit of AWS name dropping, but if you ever think the cloud is not enough for you, and especially the compute cloud from a security standpoint, please give us the opportunity to introduce you to our Nitro platform, which is a hardware hypervisor for I/O and a very, very, very thin software hypervisor, and it keeps people away from the data. So that's the next thing which we invest into. Do I have a back here? Yes, I have a back. Where we invest into is something which we call zero privileged operations. If you share something, and that's irrelevant whether it's a line, a device, or a CPU, you immediately have a security risk. Sharing always comes with risk. On the other side, if there is no risk, there is no business. Yeah. In the perfect IT world, everyone would have as many CPU in his hand as possible, and the only reason why we can't do that is that the chips are too expensive on the wafers. So we need to share them. And why is not everyone running around with his own frequency spectrum for his device? Well, because we need to share the frequency spectrum between customers. Why is not everyone running around with his own fiber optic? Well, it's too expensive. So we are in the sharing business, and we are looking into zero privileged operation, which is what we solve on our side with the Nitro system, that we move out the I/O from CPUs to hardware, which is great. And customers can basically get this right now. So if you ever want to go into the design pattern to say, well, I want to run my proxies or my metering systems or my counting of packets for my customers, not on the tower, if I really want to run this in the cloud, we can give you opportunities where you are basically the only tenant on your environment. And that also leads to our implementation of Graviton 3, which is a CPU. It's ARM-based, and there's a lot of important stuff in there, including the CPU technologies, but maybe it's a little bit too deep now. I don't know. So, questions, please.
As I work with both Bertram and Graviton, I want to praise you, AWS.
Oh, someone's praising us. Thank you.
For being one of the few hackathons who understands how important it is to move cybersecurity to hardware.
Mm-hmm.
Maybe actually we should talk also to, because there are a bunch of Romanian guys here figuring out how to solve cybersecurity and explain that a little bit. Why is this more valuable? Why the strategy of AWS is superior to wireless?
Yeah.
Unless you talk about Nitro and Graviton.
Yeah, we definitely can organize sessions. I didn't want to use 20 minutes of your time to do a deep dive on CPU technology, but we're here together. We can organize follow-ups and dive deeper. And thank you for the hint that we move cybersecurity to the chips. That's another thing I have seen in the last 34 years. Technology comes in waves. As I mentioned, I started with a telex typewriter, and there has been a mainframe on the other side. And some years later, I had a full-blown PC, 386 under my desk, and did everything there, and no mainframe anymore. That held a little bit. That moved back to web servers, and basically, for those who don't know, a web server is nothing else than a terminal preprocessor, to be precise, to a mainframe, which is not a mainframe, which is cut it down in little servers. But basically, we are swimming forward and backward between client side and server side. Nowadays, the cell phones get much more performance, and we'll see the AI systems moving into the cell phones, right? And that does mean we have a wave back to the endpoint device, which is actually running, and that's the same in cybersecurity. It's swimming between hardware implementation, software implementation, hardware implementation, software implementation, because the software is more agile. Yeah, if we look into post-quantum crypto, that needs to be in the hardware sooner or later. Actually, we only can, well, not only, but we need to test it in software first, and then it's going into hardware. And that's, fortunately, the circles on the hardware side are quicker. So that does mean, another thing I think I have now 4 parts which are recurring is the circle between software and hardware implementations. And if we are precise, hardware is also software. But to summarize that, culture is staying with us. We need to keep the culture up. Without security culture, we'll lose. Second of all, as we just had the backwards and forward cycles between hardware and software, agility in crypto is something which is repeating, coming, and we need to be ready for change. and as a community between the cloud provider and the telcos. And we're also providing networking. In this community, we need to find the overlapping parts, for example, with TLS or Quick and the fundamental stuff, and work it from there. Thank you for your time.